Howdy folks, Doc here with Last Best Tool, and today I'm going to do a quick test of some shop glasses in regard to their protection from UVB light. UVB light is a little bit more intense, a little more powerful than UVA. UVA often causes your skin to tan a little bit. UVB causes your skin to burn and could damage your eyes. And so what I've done is I've gathered up around the homestead a handful of different safety glasses, work glasses, sunglasses, etc. And I've set up a sensor here. This is a Vernier UVB sensor, and it's pointing directly into a UVB light source. Most UVB light sources are pretty specific, designed for kind of unique jobs. A lot of the UV sources you get for shop work are more UVA. They're still definitely in the ultraviolet spectrum, but they're a little bit longer wavelength than the UVB. So what I've got is a sensor hooked up here. It's pointing directly at this UV light, and then I've got my a LabQuest 3 by Vernier, which is their new kind of platform for connecting digital sensors. Running experiments, and I zeroed it out so it's 0 watts or milliwatts per meter squared. I'm going to turn on my light source here, so you won't see any change on your end, but the sensor is picking this up, and it's going to run it up about 38 milliwatts per square meter, and around outside I'd get maybe close to 70 in the sun, maybe a little higher depending on the time of the year, what's in the atmosphere. So then what I'm going to do is take a pair of glasses and just insert it directly between the sensor and the light source right here to watch what happens. So what I've got here are a pair of Smith sunglasses. They're a glass lens, higher quality. I would expect good performance out of these, so I insert them right in between. You're watching this drop. The screen times out because I'm not actually running an experiment, so it's like your phone if you're not really doing anything. Anyway, I'm going to just let it go till it's under 1. That's good enough for me saying it's working. So I'll try these yellow snap-ons. These actually are pretty good work glasses, also for shooting and certain atmospheric conditions. They can be a little bit nicer than a clear lens or a darker lens. So these are dropping it down under 1. Good enough there. Let's try these. These are they're a Milwaukee sunglass. You can see the little Milwaukee lightning bolt here. And then they've got a darker lens. So for outside brighter work, let's keep this on. So it was up over 40. Now we're dropping 12, 9. So you can see it makes a pretty big dent in UVB transmittance. Good enough on that one. Here's a nice pair of what are these, snap-ons here. These are clear work glasses. I did a kind of an unboxing with these, so you can see it's dropping pretty fast, even though that's a pretty clear lens. Turns out this one will take it below that 0.1 or 1 as well. Let's see, these are generic glasses, generic safety glasses, nothing fancy about those. So you can see it's climbing back up. I'll just interrupt its climb, drop these in. You can see, again, it's a pretty quick drop, and even though these polycarbonate generic work glasses, safety glasses, probably inexpensive, it does still have very good UVB protection. These are reading glasses. They're magnified. I use these when I'm using precision screwdrivers, which is what's over here, because I'm actually starting to get ready to do a video on precision screwdrivers. I got a request from a commenter that to do something with those, so I thought, yeah, I'll set that up, play with it. But anyway, what do these reading glasses do? Even though they got magnified lenses, Obviously you can see a quick drop, no problem there. And for fun, I've got these kind of spectrum fireworks glasses. These actually are designed to make light sources break up into their individual wavelengths of color, so they look pretty cool, rainbow glasses. And what happens with these? I wouldn't use these as sunglasses, but it turns out these also block much of the UVB. And I am under one. I also did this. I took a soda bottle here, or pop bottle, I guess, depending on which side of the Mississippi you live on. And I cut a chunk out of it. There you go. It was right there. So let's see how the pop bottle does. Drop that in. And apparently this works quite well as a UVB block. Turns out a lot of materials block UVB. A lot of materials can protect you from getting a sunburn. So what's going on here? Well, UVB doesn't get through a lot of materials. That's why you don't get sunburned inside your car. That's why, you know, you roll down your window and let your arm hang out, and the only thing that burns is your arm. UVB is much easier to block than UVA. But a lot of things do it, even clothing, t-shirts. And you might know that your sun protection factor number on your fishing shirt or whatever you wear, your outdoor shirt, is actually a UVB and UVA blocker, probably UVA, for preventing sunburn. So it's pretty easy to do. So when you see things listed as blocking UVB or UV light, it probably does. And there are a lot of inherent materials, including polycarbonate plastics, that do it just through simple existence. In order for UVB to be going through this light out in here, and turn that towards you here, what's going on here is it's using mica, like the rock. That's one of the few things that transmits UVB light and UVA light pretty well. So if you were to get a flashlight that had a UVB lens on it, you'd need a special material covering the lens because the normal lens coverings of plastic would block it. UVB, it's not, or UVA is not as big a problem. But anyway, thought you might find that interesting. So take care of your eyes as we head into summer. Feels like it anyway. With that, Doc out.